Good morning, dear students. So in today's class, we'll begin the second module. And in second module, we'll discuss about the first order nonlinear PDE and how to find its solution. And in today's class, we'll be looking at what do you mean by the solution of a nonlinear PDE. ഇപ്പം നിങ്ങളുടെ സൊല്യൂഷൻസ് എന്ന് പറയുമ്പോൾ there can be general solutions and particular solutions. So in this way, the solution can be of different types for a nonlinear PDE. So in the first class of the second module, we are going to look at what are the different types of solution and how to find out the different types of the solution for the PDE. So in general, I'll be representing a first order nonlinear PDE in the form f of x, y, z, pq equal to 0. So that's an equation involving x, y, z and the first order partial derivatives p and q. So this is dou z by dou x and dou z by dou y. And for a nonlinear PDE, so this is a function such that p and q are not linear. So f is not linear in p and q. So let me call it as equation 1. Initially we have seen how to form different PDEs. So when you have an equation of the form f of x, y, z, a, b equal to 0. So it's a 2-parameter family of surfaces. We have seen already that 2-parameter family of surfaces നമ്മൾ solve ചെയ്യുമ്പോൾ, so if the number of independent variables is equal to the number of arbitrary constants, so you are going to get an equation of the form 1. So അതുപോലെ തന്നെ നമ്മളിവിടെ nonlinear PDE solve ചെയ്യുമ്പോഴും again you are going to get an equation of the form f of x, y, z, a, b equal to 0. So that's how the solution of the equation 1 looks. So we'll see the definitions of various types of solutions. So you consider the solution of the form f of x, y, z, a, b equal to 0. Now if, so which is your equation 2. Now if f of x, y, z, a, b equal to 0 is a solution, then any envelope of this 2-parameter system, that will again satisfy equation 1. അപ്പോൾ എഫ് ഓഫ് എക്സ് വൈ സെഡ് എ ബി ഈക്വൽ ടു 0 എന്ന് പറയുന്നത് നമ്മുടെ പി ഡിയുടെ സൊല്യൂഷൻ ആണെങ്കിൽ വെൻ ഐ ഫൈൻഡ് an envelope, so the envelope also touches your surface at each point. So the given envelope is also going to satisfy the conditions of PD. So therefore the envelope is also a solution of the partial differential equation 1. So which is f of x, y, z, pq equal to 0. So this idea is going to give us the 3 different types of solutions or integrals of the equation. So the different types of solutions are obtained as envelopes of the system f of x, y, z, a, b equal to 0. So we'll define the first type of solution. So first type of solution of a nonlinear PDE is that is called a complete integral. So the complete integral is solution of the form f of x, y, z, a, b equal to 0. So a 2-parameter system of surfaces f of x, y, z, a, b equal to 0 which satisfies a given PDE is called a complete integral of the PDE. Now the second type of solution is called the general integral. Now general integral is obtained when there is a relation of the form b equal to xi of a between the parameters. So f of x, y, z, a, b equal to 0 ആണ് complete integral. And നമുക്ക് എയും ബിയും തമ്മിൽ ഒരു റിലേഷൻ എക്സിസ്റ്റ് ചെയ്യുവാണെങ്കിൽ, so the entire equation can be put in terms of x, y, z and a. You can replace b by psi of a. So you are going to get f of x, y, z, a, psi of a equal to 0. ഇനി ഇതെന്ന് പറയുന്ന ഒരു 1-parameter system of solution ആണ്. So this is going to satisfy your PDE. Now find the envelope of this. So find the envelope of f of x, y, z, a, psi of a equal to 0. So the envelope of this equation is called the general integral of your PDE. Okay. For finding the envelope, and the dou f by differentiate with respect to the arbitrary constant. So dou f by dou a equal to 0. So you have the equation f of x y z a is I of a equal to 0 എന്ന് പറയുന്ന equation ഉണ്ട്. Then dou f by dou a equal to 0. So using these two equations, eliminate a. So that will give you the envelope. So this becomes the general integral of the given PDE1. And the third type of solution is the singular integral. So the singular integral is obtained by finding the envelope of the two parameter system. അതായത് നമുക്ക് f of x y z a b equal to 0 എന്ന് പറയുന്നതാണ് നമ്മുടെ കംപ്ലീറ്റ് ഇൻ്റഗ്രൽ. അപ്പോൾ കംപ്ലീറ്റ് ഇൻ്റഗ്രലിന് you differentiate with respect to a. So take dou f by dou a equal to 0 and dou f by dou b equal to 0. Then eliminate a and b. So the envelope so formed will be called as the singular integral. So general integral is the one parameter subsystem കണ്ടുപിടിക്കുക, അതിൻ്റെ envelope ആണ് general integral. Then singular integral is, so from the two parameter system, find the envelope. So find the envelope of the two parameter system. That will be the singular integral. So we'll see an example of finding all the three integrals. So the question is, verify that z equal to ax plus by plus a plus b minus ab is a complete integral of the PDE. Z equal to px plus qy plus b plus q minus pq, ab being arbitrary constants. Show also that the envelope of all planes corresponding to complete integrals this provides singular integral of the differential equation, and determine a general integral by finding the envelope of the planes that pass through the origin. Okay. So by the complete integrals, you need to verify that z equal to ax plus by plus a plus b minus ab is a complete integral of the PD. Okay. So here you are given a function of the form f of x y z a b equal to 0. So complete integral ആണോ check ചെയ്യാൻ, so just verify that z satisfies this equation. അപ്പോൾ then z ഇതാണ്. So z ഈ PD satisfy ചെയ്യുന്നുണ്ടോ ഇല്ലയോ എന്ന് check ചെയ്യുക. Okay. So we will see the solution. So f of x y z a b is z minus ax plus by plus a plus b minus ab. When you find p, so dou z by dou x is going to be equal to a. ഈ equation in the dou z by dou x is a, and dou z by dou y is equal to b. That means p is equal to a and q is equal to b. So you replace a by p and b by q. That is going to give you the equation of the PD. So hence we can show that z equal to ax plus by plus a plus b minus ab is a solution of this PD, and hence this is going to be a complete integral since it is of the form f of x y z a b equal to 0. അപ്പോൾ ഇത് കംപ്ലീറ്റ് ഇൻ്റഗ്രൽ ആണ്, നമ്മുടെ പി ഡിയുടെ കംപ്ലീറ്റ് ഇൻ്റഗ്രൽ ആണ് തന്നിരിക്കുന്ന സൊല്യൂഷൻ. നൗ യു ക്യാൻ സീ ദാറ്റ് ദിസ് സൊല്യൂഷൻസ് ദേ ആർ പ്ലെയിൻസ്. ഓക്കെ. സോ ഇതെന്ന് പറയുന്നത് ഇഫ് യു ടേക്ക് എ എക്സ് പ്ലസ് ബി വൈ മൈനസ് സെഡ് plus a plus b minus ab equal to 0. So they are equation of planes in the three-dimensional space. Now you need to show that the second part of the question is show that the envelope of all planes corresponding to the complete integrals provides singular integral of the differential equation. From a system of planes into envelope kandupidikkya. So when you find the envelope, show that it provides you the singular integral. അപ്പം ഇതിൻ്റെ envelope കണ്ടുപിടിക്കാൻ you need to find dou f by dou a and dou f by dou b. So from the equations f equal to 0, dou f by dou a equal to 0 and dou f by dou b equal to 0, you need to eliminate a and b. Okay. So dou f by dou a equal to 0 എടുക്കുമ്പോൾ you will get minus of x plus 1 plus b equal to 0. Dou f by dou b equal to 0 എടുക്കുമ്പോൾ minus of y plus 1 plus a equal to 0. So on eliminating a and b, so a will be y plus 1, b is x plus 1. Ni original equation substitute here. So substitute for a and b. So on simplifying, you are going to get z equal to x plus 1 into y plus 1. So therefore, this is the envelope of the two parameter system of planes. So this forms the singular integral. The next part of the question is to determine a general integral by finding the envelope of the planes that passes through the origin. Now for general integral, you must be able to obtain a relation of the form b equal to xi of a. So I am going to write f of xyz a xi of a. Okay. So here now the equation becomes entirely in terms of a. B nu parayna arbitrary constant illa. So now you need to find the envelope of this. So for finding that, I'll take dou f by dou a equal to 0 and you need to find the envelope which is passing through the origin. So when I substitute origin means x equal to y equal to z equal to 0 varum. ഈ ഇക്വേഷനിൽ ഞാൻ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ when I am substituting the origin in the equation of f equal to 0, so I am going to get the condition minus a minus I of a plus a xi of a equal to 0. So that condition is going to give me what is the value of xi of a. So xi of a എന്ന് പറയുന്നത് a by a minus 1 വരും. So on differentiating, xi dash of a is minus 1 by a minus 1 whole square. ഇനി xiയും xi ഡാഷും ഈ ഇക്വേഷന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക and then you eliminate a from that. So on substituting xi and xi dash in the equation dou f by dou a equal to 0, നമുക്ക് ഇങ്ങനെ കിട്ടും x minus y by a minus 1 whole square plus 1 minus 1 by a minus 1 whole square plus a by a minus 1 plus a by a minus 1. അപ്പം ഈ ടേംസ് സിംപ്ലിഫൈ ചെയ്യുക. 4 ടേംസ് സിംപ്ലിഫൈ ചെയ്യുമ്പോൾ you will get in this form. So this is going to cancel out. So that is going to give me x equal to y by a minus 1 whole square. So I'll get a minus 1 as root of y by x. So which gives a equal to root of y by x plus 1. Okay, അപ്പം a യുടെ വാല്യൂ കിട്ടി. So അതിൽ നിന്ന് I can find what is xi of a. ഇനി a യുടെ വാല്യൂ I have obtained in terms of x and y. ഇനി അതുപോലെ xi of a എന്ന് പറയുന്നത് റൂട്ട് y പ്ലസ് റൂട്ട് എക്സ് ബൈ സ്ക്വയർ റൂട്ട് ഓഫ് y വരും. ഇനി ഇത് നമുക്ക് ഈ ഇക്വേഷന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. Our aim is to eliminate a. So we have obtained a and xi of a in terms of x and y. So substitute in the equation f equal to 0. So on substituting in the equation f equal to 0, so this is what you are going to get. On simplifying, so you will get z equal to root of xy plus x plus root of xy plus y. So that is z equal to 2 root of xy plus x plus y. So you can remove the square root here, the square. So that gives x minus y, z minus x minus y whole square equal to 4xy. So this is the general integral. So we have seen how to find the singular integral. A singular integral is the envelope of the two parameter system, and general integral is obtained by giving the relation b equal to xi of a. So b equal to xi of a kodukka. So you will get an equation involving a. So find the envelope of the one parameter system. So that gives the general integral. So these are the 3 different types of solution of the nonlinear PDE.